This is the first video lesson for Unit 6B, Stoichiometry. In this lesson, we'll be determining the formula mass of a compound. So take a moment to download the class packet from our website and go to page 2. Motivation: take a moment to read the passage below about formula mass, gram formula mass, and molar mass. Once you read it, answer this question. Which is bigger, 1 gram or 1 AMU? So they're both units of mass, but 1 gram is much bigger than 1 AMU. If you recall, AMU stands for atomic mass unit and is used for small things like atoms. Learning target. At the end of the lesson, I'll be able to calculate the formula mass and the gram formula mass of a molecule and hydrates. Homework read number 1, which will be a junipod based off this lesson. Formula mass is calculated by adding up all the atomic masses of the atoms in the molecule. If you recall, atomic mass of each element can be found on the periodic table. For example, what's the formula mass of HF? So HF is a molecule. It contains the atoms of hydrogen and fluorine. So hydrogen has atomic mass of about 1, but fluorine is about 19. So the formula mass of HF is just adding up these two numbers, which is about 20 AMU. So gram formula mass, or GFM, is also known as molar mass. GFM is calculated the same way as formula mass, basically by adding up all the atomic masses of the atoms in the molecule. So the only difference between formula mass and GFM is the units. The unit for formula mass is AMU, the units for GFM is grams over moles. If moles are assumed to be 1, then the units for GFM is grams. So here's the procedure of calculating the formula mass. You first look up the mass of each element on the periodic table and round it off. Multiply each element's atomic mass by a subscript to get the product, and add the products together to get the total. So here's an example of copper sulfate. In the example, we first look up the atomic masses of each element in the chemical formula, then we multiply the atomic mass by their subscript in the chemical formula, we add them up, and that will be the formula mass of the compound. So let's do another example. Here's water. So the first step is to look up the mass of each element on the periodic table and round it off. So hydrogen will have atomic mass of 1, oxygen will have atomic mass of 16. The next step is to multiply each element's atomic mass by its subscript to get the product. So the subscript of hydrogen in the water is 2, oxygen will be 1, because 1's invisible. Then we multiply the mass by the subscript to get the product. And then for step 3, we add up the products together to get the formula mass. So the formula mass of water will be 18 AMU. So learning check number 1, what is the formula mass of CO2? Pause the video and resume once completed. So if you add up all the atomic masses of the atoms in CO2, you'll get 44. Learning check number 2, what is the gram formula mass of calcium hydroxide? Pause the video and resume once completed. So gram formula mass is calculated the same way as formula mass. So notice we have a parentheses here. So this 2 is distributed into the oxygen and the hydrogen. So we have 2 oxygen and 2 hydrogen. So in this chemical formula, we have 1 calcium, 2 oxygen, and 2 hydrogens. So the gram formula mass should be 74. Choice 4. So now I want you to do the rest of the examples by yourself. Pause the video and resume once you complete it. So here are the answers. So N2O5 has a formula mass of 108 AMU. Mg3P2 has a formula mass of 134 AMU. The formula mass of ammonium oxide is 52 AMU. Now for the next practice, I want you to solve for the gram formula mass of the following. So remember to write the units. The gram formula mass is calculated the same way as formula mass, except different units. It has units in grams per mole. Pause the video and resume once completed. Here are the answers. Next, we're going to talk about hydrate. Anhydrate is an ionic compound which has water molecules embedded in the crystal. Here's an example of a hydrate. If you see a chemical formula with a dot and water, that should tell you that this compound is a hydrate. This is the hydrate of cobalt 2 chloride. For every cobalt 2 chloride, there are 6 water molecules. Here's how you would calculate the formula mass of a hydrate. You have to add up the mass of the ionic compound and the number of water molecules. So here's an example of the calculations. We have 1 cobalt here, we have 2 chlorides, and since we have 6 water molecules, we have 12 hydrogens and 6 oxygen. If you add them up, this will be the gram formula mass of this hydrate. For naming hydrates, we're going to use the ionic naming rules. Since there's the ionic compounds, there's one additional step. You must add a prefix next to the hydrate. The prefix is based off the number of water molecules. For example, we see 6 water molecule, so the prefix will be hexahydrate. In this example, we have 6 water molecule, so the prefix for the hydrate will be hexa, and CoCl2 is cobalt 2 chloride. That's based off the ionic naming rules, so the name of this hydrate will be cobalt 2 chloride hexahydrate. Learning check number 3. What is the gram formula mass of this hydrate? Pause the video and resume what's completed. So the answer is 250, choice 2. Learning check number 4. What is the chemical name of this hydrate? Pause the video and resume what's completed. So this is copper 2 sulfate, and then there's 5 water molecule, so it's pentahydrate, because 5 has a prefix of penta, so the answer is choice 4. Copper 2 sulfate pentahydrate. Here's the structure of the hydrate of cobalt 2 chloride tetrahydrate. So the bond between the cobalt and the water molecule is called a coordinate bond. A coordinate bond is a covalent bond formed in which 2 electrons derive from the same atom. So in this case, the electrons in the bond is coming from the oxygen, not the cobalt. The cobalt is not contributing any electrons in this bond. So the Regents doesn't really ask any questions about coordinate bonds anymore. Check of understanding. Are hydrates mixtures of pure substances, and why? Hydrates are compounds, and compounds are considered pure substances. If you recall, the difference between a mixture and a compound is the ratios. In mixture, the ratio can vary, but in compounds, the ratio is fixed. So in this example, water is embedded in the crystal structure of the ionic compound and is a fixed ratio. So the ratio between the ionic compound and water in this example is 1 to 4. Check of understanding number 2. What happens if we heat a hydrate? In this example, we have cobalt 2 chloride hexahydrate. If you heat any hydrate, water is removed. The water will evaporate from the hydrate. Here we have different examples of hydrates of cobalt 2 chloride. Notice when water is removed, the color changes for the substance. If we look at the crystal structure, you see that the structure is different. So each hydrate of cobalt 2 chloride is a different substance. So when you heat up a hydrate, is that considered a chemical or physical change? It is considered a chemical change. Why? Because the hydrate is a different substance than the ionic compound itself. When you heat up a hydrate, water is evaporated, it leaves the hydrate. Since water leaves when you heat up a hydrate, it is considered anhydrous, which means dry, no water. An means negative or no, hydrous means water. So no water means dry. The cobalt 2 chloride is an anhydrate, which means a hydrate with no water. For the remainder of the practice, I want you to figure out the GFM and the name of each hydrate. Pause the video and resume once completed. So here's the answers. So the name is barium chloride dihydrate, and here's the GFM. For question 2, it is mercury 2 nitrate monohydrate, and here's the GFM. For question 3, it is copper 2 chloride pentahydrate, and here's the GFM. For number 4 is barium hydroxide octahydrate, and here's the GFM. For number 5 is calcium sulfate pentahydrate, and here's the GFM. And for the last one, it is iron 2 fluoride tetrahydrate, and here's the GFM. So this concludes the video lesson for today. Remember to do the Junipod homework.